Okay, in today's video, we're going to cover the fundamental principle of counting, how to calculate permutations, and how to calculate combinations. So elementary school, counting was probably just 1, 2, 3, 4, 5, what comes next? But as we get older, we're going to see that counting really is more like how many possible outcomes are there? How many possible groups? How many possible ways? In this video, we're going to cover the tools you need to answer these questions. Okay, this problem, we see that I have 4 pairs of jeans and 5 different t-shirts. If an outfit composes of a pair of jeans and a t-shirt, how many possible outfits can I wear? So first, we have to give these jeans and t-shirts names. So, well, not like Bob, but something methodical. So for jeans, we're gonna have J1, J2, J3, and J4. For t-shirts, we're gonna give them T1, T2, T3, T4, and T5. Now we have to see how many ways we have to combine these two. You could try to list them all by hand, but there's going to be too many to list them, and you're probably going to make a mistake. So we need a methodical way to do this, clean way. So we can do that with just a grid. Okay. So with the grid here, we see that we have every distinct possible outfit, J1, J2, J3, J4, and all the way to 5. And for the question, how many possible outfits, that's just asking how many squares are there in this grid. And to answer that, we could multiply. And for this problem, it's no coincidence that we can multiply. The reason we can multiply is because of the fundamental principle of counting. When we have a question like this, we can always multiply. So for jeans, we have 4 choices. For t-shirts, we have 5 choices. So that means there's 20 outfits. Not too bad, right? Okay, next one. At a sub shop, you can order your meatball sub in 2 sizes, with or without cheese, and you get your choice of 8 different types of bread. How many different meatball subs are available? Okay, so we have the same bars from last time. For sizes, we have 2 sizes, so we have 2 choices, with or without cheese, so we have 2 options for cheese or no cheese. And we have 8 different types of bread. I can't even name 8 different types of bread, but I guess there's 8 choices for that. Okay. So now we have to multiply all these because it's a fundamental principle of counting. So 2 times 2, 4, 4 times 8 is 32, so we have 32 different subs. Okay. Now that we know how to do basic counting, let's do some permutations. So I have one math book. In how many ways can I arrange this book on my shelf? Well, it's just one math book, so there's only one way to do that. So one way. Okay, let's bump it up a notch. I have 2 math books. In how many ways can I arrange these books on my shelf? Okay. So for the first book, there's 2 choices. And now that we have chosen a book for the first one, we only have one option left. So it's going to be 2 times 1, 2 ways. I have 3 math books. In how many ways can I arrange these books on my shelf? Okay, same thing as last time. So 3. And now that we chose that one for the first lot, we're only going to have 2 left. And now that we've chosen 2, we are going to have 1 left now. So it's going to be 3 times 2 times 1, which is 6. So 6 ways. Okay. Now 4 math books. And how many ways can I arrange these books on my shelf? Okay. 4 books for the first option, 3 for the next, 2 for the next, and we're going to have 1 left over. So it's going to be 24. I have X math books. And how many ways can I arrange these books on my shelf? Okay. Let's treat X as a normal number. X times X minus 1 times X minus 2. And notice that this is exactly what we were doing for the first view. 4 times 4 minus 1 times 4 minus 2. And we're going to keep going until we get to 1. Because in all these problems, we kept multiplying until we got to 1. And here, this notation is known as factorial. So the answer is x factorial. So a factorial is when you multiply a number by all the numbers that go before it. So here, the answer is 1 factorial, the answer is 2 factorial, then 3 factorial, 4 factorial, now x factorial. Okay. Let's go on to some more permutation problems. 10 students are playing Kahoot. In how many ways can the students play first, second, and third? Okay, so for the first student, there's 10 students to choose from, as nothing's been done yet. And now that one of them got first place, we're only going to have 9 possible for the second choice. And for the third choice, we're going to have 8 now. So it's going to be 10 times 9 times 8, so 72 times 10. So 720 ways for the students to place first, second, and third. And this is a permutation, which is when we count the number of arrangements there are. So permutation is just a fancy word for arrangements. And we can write these problems in permutation notation, which is just a P. 10P3 is how we would write the problem above, which is read as 10 permute 3 or 10 order 3, suggesting how many ways can we arrange 3 objects in a set of 10. At IB, a student government is started. There are 5 students for any of the 4 positions, which means they want to get a position, they don't care which one. President, vice president, secretary, and treasurer. How many possible outcomes are there for IB's election results? Okay, this is the same one as last time. So for president, we have 5 possible students. And once the president gets chosen, we're only going to have 4 students left for vice president. And then for secretary, we're going to have 3. And then for treasurer, we're going to have 2. And 5 times 4 times 3 times 2 is 120. Alternatively, 5 permute 4 is equal to 120. That's another way to think of this problem. Okay. Now we're going to move on to combinations. There are 20 students in Rossi's classroom. She tells the class to split into groups of 2. How many possible groups are there? Okay, now we see that there's no leadership, they don't have any roles here. We just want to split them into groups by choosing. That's why this is a combination problem, not a permutation. It's combinations, we're only choosing, we don't care about order. And for permutations, we do care about order. So first, for student 1, we have 20 options. And for student 2, we have 19 options. But the problem is that this calculation is treating AB, let's say student A and student B is a group, and student BA, it's treating these two as different possibilities. Okay, if we were to go on the grid above, if we had A, AB, and AB here again, for the purposes of the grid, AB and BA, it can't tell the difference between those two. And we have to divide by 2 to account for that. Let's go back. Because there are 2 ways to arrange these 2 letters. So we're going to do 20 times 19 divided by 2 factorial. Because 2 factorial is the number of ways there are to arrange that. And 2 factorial is 2. So 20 times 19 divided by 2. So 20 times 19 is 380, divided by 2 is 190. Hopefully it makes more sense with the next one. There are 20 students in Rossi's classroom. She tells the class to split into groups of 3. How many possible groups are there? Okay, so for student 1, we have 20 choices. For student 2, we're going to have 19 choices. And for student 3, we're going to have 18 choices. So let's think of these as A, B, and C. How many ways are there to arrange A, B, and C? Well, there's three for the first one, three choices for the first one, two for the second, and one for the last. So there's three factorial ways to arrange these three students. We're dividing because we want to account for overcounting, because we're gonna have B, A, C, and so on. There's gonna be a lot of duplicates, and when we divide by 3 factorial, we get rid of those duplicates. Okay, so 20 times 19 times 18 divided by 3 factorial. We're gonna need a calculator for that. Okay. 20 times 19 times 18 divided by 3 factorial, which is 6. So, okay, and we get 1140. There's 1140 groups. Okay, let's review. Okay, before we review, for these problems, since it's a combination, it's going to be similar to permutations, how we had 8 permute 3. Instead here, we're going to have, for this problem, we had 20 choose 3. Choose for a combination. So we just write a little C, and we do this process. Okay, so time for review. 8 permute 4. So we have 4 slots, 1, 2, 3, 4. For the first one, we have 8 options, then 7, then 6, then 5. Let's split this up. So 56 times 30 is equal to 8 permute 4. Let's put that into a calculator. 56 times 30 is 1,680. That means that 8 permute 4, oh, I don't know what that is equal to 1,680. Okay, 5 permute 5, so we're going to have 5 slots. This one, we have 5 options. For next, we have 4, then 3, 2, and 1. We have 5 times 4, 20, times 3, 60, times 2, 120, times 1, 120. So 5 permute 5 is equal to 120. Okay, now for 9 permute 3, we have 3 slots, 9 choices for the first, 8 for the second, and 7 for the third. Okay, so 72 times 7. Okay, 504. So 9 permute 3 is 504. Okay, now for 10 choose 2, we have 2 slots, 10 choices for the first, 9 for the second, and then we divide by the number of ways there are to arrange these two, and that's going to be 2 factorial. So 10 times 9 divided by 2 factorial, which is 2. So 90 divided by 2 is equal to 45. Okay, now for 12 choose 3, we have 3 slots, and for this one we have 12 options, then 11, and then 10. We're going to divide by the number of ways there are to arrange these 3. It's going to be 3 factorial. So it's going to be 12 times 11 times 10 divided by 3 factorial, which is 6. Let's put that into the calculator. 12 times 11 times 10 divided by 6 is equal to 220. So 12 choose 3 is 220. Sorry about that too. Okay. 4 choose 1. We have 1 slot. We have 4 choices for that slot. And we divide by how many ways there are to arrange it. So 1. Okay, here's a challenge. Can you find a general rule for X choose 1? I'll leave you to that. Okay. Clear these ones for the next problem. Okay. This one. 100 factorial, 98 factorial, divided by 98 times 99 factorial times 97 factorial. You could do 100 times 99 times 98 times 97 times 96 and so on, but there's got to be a cleaner method to do that. So first, let's observe a property of factorials. 5 factorial is 5 times 4 times 3 times 2 times 1. And the property is that factorials contain other factorials. So here, 5 factorial can also be written as 5 times 4 factorial. And with this rule, we can rewrite 100 factorial. So 100 factorial, we can rewrite that as 100 factorial can be written as 100 times 99 factorial times 8 factorial, goes up here, and we divide that by 98 times 99 factorial times 97 factorial. Okay. And when we have products like these and fractions, we can cancel out things that are the same. So 99 factorial shows up in the top and the bottom, so you can cross that out. And we're left with 100 times 98 factorial divided by 98 times 97 factorial. That's a whole lot simpler. Okay, so 100 times 98 factorial divided by 98 times 97 factorial. Okay, we can rewrite 98 factorial as 98 times 97 factorial. So let's do that. 100 times 98 times 97 factorial divided by 98 times 97 factorial. And here, in both the numerator and the denominator, we have 98 times 97 factorial, so we can cancel that out. And our final answer is 100.